How's it going, everybody? My name is Alex, and today I'm going to be making a real quick tutorial in Unreal Engine 5.2 on how to build a simple little procedural scatter spawner. That in this example I'm spawning mushrooms, but you'll essentially be able to plug anything you want into this. The video is going to be in two parts. The first part, real simple, quick, step-by-step of exactly how to build this as it looks here. Second part, I'm going to be diving a little bit more into the theory, the concepts, what's happening under the hood, and kind of spending a little bit more time configuring some of this, creating some attributes that you'll be able to tweak in blueprints as parameters, and yeah, it should be fun. First things first, sorry, we're going to go into edit, plugins, and you need to make sure that you actually have the procedural content tools turned on. So when you're in plugins, if you type in procedural, make sure this one's turned on, procedural content generation framework, and then after that, this one here, geometry script with the experimental tag. This is brand new stuff. Maybe it won't have an experimental tag when you're watching this. You know, you might not even technically need to enable these things in the future. I mean, you probably won't, but for now, let's just assume that they're not enabled and go in and just make sure that that stuff is all ticked. And then once you've done that, you'll be good to go. You'll see that once they're enabled, you'll get this nice PCG subcategory on your right-click menu in the content browser. So yeah, let's get on with the tutorial. So the first thing we're going to do, I'm going to make a new folder. I'm going to call it mushroom spawner, you know, something relevant, something that makes sense for what we're doing. We're going to right click. You'll now have a sub menu on the on here for PCG. I'm going to create a PCG graph. Again, name it something relevant. You'll spot a trend here with my naming conventions. Mushroom spawner, right click again, blueprint class, actor. I'm going to call this one BP underscore mushroom spawner. Again, incredibly creative with these names, incredibly creative. I'm going to open up the PCG graph, right click, get spline data. Okay, now we need to let it know which spline it wants to look for. So on the filter on tags, add a new one. Just put anything memorable and simple, so you'll be able to copy it over afterwards. So now it's going to be looking for the spline with the tag mush spawner. Very, I should have maybe picked something other than toadstools to create this tutorial. The mushroom is already starting to sound not like a real word to me. I'm going to open up the blueprint next. Once you've done that, wait for it to configure. Okay, here we go. Now we're in the blueprint. Make sure you're on the viewport tab. You're going to click plus, search PCG, and now you'll have this there. Click that. Where it says instance in the details panel, click the drop down, and the graph that you've just created, select that. So now this PCG graph will be contained in the blueprint, and it's going to be the graph that we've just created. That makes sense, right? I'm sure it does. Next, we're going to click plus again, add a spline, drop that in there. Going to make this a little bit bigger. You don't really need to make it bigger because you can edit it in the on the level editor, but I think it just makes it a little bit easier to edit it or to make it a little bit bigger up front so that you're just able to see what you're doing. So I'm going to just bring it out to about here, and you're going to hold Alt, grab the arrow, and then if you're holding Alt and you move something, you actually duplicate it. So we add an extra point to the spline. Once again, Alt, click and drag, add an extra point. So now we've got 4 points to the spline, and if you see this button here, close loop, you're going to tick that. And there we have a full complete loop, complete spline. But if you remember, we were looking over here in the get spline data node for a spline with the tag mush spawner. So I'm going to just Control C from there, Go back over, make sure you've got the spline selected in the component list. Go down to component tags, click plus to add a new tag, get rid of none and add mushroom spawner. So now the graph will be looking for a spline with mush spawner, and I'll guess what, it's bound one, the one that we've just made. Isn't that handy? Isn't that lovely? Okay, so now what we're going to do, I'll take the blueprint that we've just created, drag it onto the level, and now we have this there. We need to generate some points, need to give it something to work with. So next we're going to do sample spline sampler. So once you've got the spline sampler, you want to click this and make sure the dimension is set to on interior. At the moment it's on spline, which means it will be creating points on the actual spline itself. We don't want that. We're going to be using the spline as a kind of perimeter or a bounds for where we want the mushrooms to be spawning. So we want to make sure that the dimension is set to on interior. I'm going to go to interior sample spacing. I'm going to set this to like 25. This will generate more points within the bounds that we've established. If you press D on any of the nodes, you bring up the debug. The default debug cube is huge. So if you want to change that, where it says debug here, you go to absolute scaling, and then you can change this to like 0.05, say. And now we get much smaller points, or much smaller debug cubes, which allows us to visualize the points a little bit more accurately. From there, we're going to do density noise, add that. From there, we want density filter. From there, again, this is the speedrun version of the tutorial, and it's still kind of long. So stick around afterwards for the theory about exactly what we're doing here, but for now, it's literally just going to be copy what I'm doing and you'll see the result that we get. So from density filter, we want a static mesh spawner. But first, if we go back here, we'll put it here. If we bring this across, alt click on an output or an input to delete the string between them. So we're going to do world array hit query, and we're also going to right click and get projection. So we're going the points that the sampler is generating will go into the projection, and then that information will be passed on to the density noise. The world array hit query, I'd say that quickly 3 times in a row. The world array hit query will go into projection target, and this will basically mean that the points will be projected onto whatever's underneath the ray trace. Again, I'll explain that concept further in part 2. Also, you want to tick on world array hit query trace complex. So from static mesh spawner, if you bring this over, we'll add now mesh entries, add descriptor, static mesh is over here. I'm going to add the mushroom. And there we go. You can change the density filter. If you increase this, it will basically remove, where have I got the debug on the spline sampler? So on the density filter, yeah, you can change the bounds on this to increase or decrease the density of the mushrooms. We're just going to add a little bit more here. If we alt click here to get that from here, we do transform points and plug it in here. It will have the meshes inherit transform data from the points. So for example, at the moment, all of these mushrooms are at a scale of 1, meaning whatever their default scale is, that's the minimum it can be, that's the maximum it can be. They will always be at their default scale. We can change that if we set the scale minimum to like 0.5, set the scale maximum to say 2. Now we'll get, some of them will be at half the size of their original mesh, and some of them will be at double the size of their original mesh. We can also add rotation on the Z axis. If we give it a range of 0 to 360 degrees on the Z axis, click that, we'll get them in random directions. And we can also maybe add some slight variation here and here on the other axes. We don't want as much because we don't want them spawning upside down, but as you can see, we get a little bit of variation. And even with only one mushrooms mesh in use, we still actually have quite an organic little selection of mushrooms. And because we built this into a spline, we can actually grab the points of the spline, drag them out, and it will increase the radius in which the mushrooms will be spawning. Also, another thing, so because we're using the trace, we can essentially spawn the mushrooms on top of stuff. You can kind of, it's a little bit finicky, but if you move the blueprint and then select the spline and move that like separately, you can kind of do different things. That's something that you might need to play with. Again, I'll explain it a bit further in part 2. You might be confused, like, oh, why is it spawning inside of a mesh? But if you look, if I go to physics, you'll see that some of these blue blocks in the default level have block all, and some of them have physics actor. So the ones with physics actor, it won't go, it won't like spawn on top of those. But if I change that to block all, we move this to make it refresh, it fixes it. Also, another quick thing, you can see how the meshes are conforming to the angle that the ray query hits. If you want to fix that, go over here into the world ray into the projection settings, and then where it says project rotations, if you untick that, it will stop that from happening, basically. So yeah, super simple. If you want a little bit more of a kind of demonstration, you can use this. I've got a rock downloaded. Now, it's tiny. Don't laugh at it. It's a tiny rock. However, be careful who you make fun of in middle school. Check out that chunky boy. We bring this over, and we'll see we get the ray queries kind of placing the mushrooms in the right place. So yeah, that's this kind of simple, very simple Cliff's Notes version of the mushroom spawner. Stick around, and I'll be going into a lot more detail and adding a few extra things, including some parameters in the blueprint, and just explaining what's kind of happening under the hood, and maybe plant the seed or plant the spore, I guess is more apropos of how you could potentially use some of this and then go off and create your own wonderful devices using the brand new PCG tools in Unreal Engine 5.2. So yeah, okay, so now that we're done with that initial setup and we're all on the same page and we all kind of have the graph in front of us, and we can kind of worry less about going through each step to get the final result, we can now kind of go back into that graph and have a look at each aspect and dissect a little bit what's actually happening under the hood, and maybe come up with a few ways in order to expand the functionality of this and make it a little bit better. So first of all, we're going to look at the get spline data node right at the beginning. What's this doing? Well, this is basically how the graph is interfacing with the level. You have to pull in the data in order to manipulate it and use it within the graph. So it's pretty simple. Now, this is kind of why I like to put this in a blueprint. Technically, if you hover on the get spline data node, you can see over here in the actor filter, it's set to self. You can set this to all world actors, and that means if you were to drag just the graph into the level, then drag a spline into the level and tag it with Mush Spawner, it would be able to use that spline. That's completely viable. I prefer to do it like this just so you don't end up with like loose ends. You know, you don't end up with like a PCG graph that isn't interacting with anything in the world and is just sort of floating around. So I like to put everything within a blueprint. That's why I've done that. And also it allows you to kind of add parameters to the blueprint later, which I'll show you how to do. So that's why initially I created a blueprint, put everything in there. I just like it for kind of housekeeping. Keep everything neat, keep everything tidy. Next up, the sampler. Now if I debug this, we'll get the points back. And actually let's, for now, remove the static mesh. And honestly, even remove the projection, I think, just because we don't like the projection. I'll talk about it briefly. Essentially what we're doing is all the points that the sampler creates, we're passing in and we're saying, hey, project these points onto something, which is the projection target. Now, the target will be the result of the WorldRay hit query. The WorldRay hit query, it's basically, I mean, you can change the settings and direction, but it's essentially sending a ray downwards, like a laser downwards, and whatever it connects with will be where these points are then projected. So, you know, think of it, I don't know, like throwing a sheet over a piece of furniture, I guess. You kind of get the outline of that furniture where the sheet has landed. It's kind of a terrible analogy, but that's essentially what that is doing. So, you know, it's important if you want these points to conform to whatever's underneath it. If you're using landscapes, you can do that differently with the input node. Has like a landscape input built in, but that's, you know, I'm not going to be covering that in this tutorial because it would end up just completely going off the rails and lasting forever, essentially. These are very in-depth tools. A lot of stuff going on. There's a lot of like nooks and crannies. I'm just kind of giving a basic overview of the things I'm using to create this, just so you know, have a bit of a better understanding. So essentially we generate points with the spline sampler, and like I mentioned before, we can change. So at the moment the points are on interior. We can change them to be on the spline, and you see we have like points here, and if you up the subdivision, let's bring it up to like 7, you'll get more points on the spline. And now if we were to like, let's just bring the mesh back. If we were to take this and plug it in, we get the mushrooms on the spline instead of on the interior, which is pretty useful. There's definitely instances where you would want to do that. If you were like, I don't know, let's say we had made like a model of a farm and we wanted to put a fence around the farm. You know, instead of mushrooms, you could have like individual fence pieces on the spline, and then you could just sort of draw the spline around the fence, and, you know, you get like a dynamic procedurally generated fence essentially, which is pretty cool. So that's, you know, something you could experiment with if you want to go a bit deeper into these tools. So yeah, for this example though, we want it to be on interior. So you can see we get a bunch of points, but they're all the same, right? Now, when we look at this, you see that all of the points are white, but you have to remember that white in this instance doesn't just represent like, oh, it's like an aesthetic choice for the point. White is representing the number 1. So if you've ever used like the shader graph or like materials and stuff like that, you'll know that white represents the number 1, black represents the number 0, and all the shades of grey in between represent all the numbers in between 0 and 1. So, you know, 0.5, for example, would be a shade of grey directly between black and white. And that's essentially what we do with density noise. If I disconnect that now, let me debug this, but I'm going to, before I even do that, let's take the scale down to 0.05. So if I turn off the debug on here and turn on the debug on density noise and drag this in, you'll see that density noise randomizes the value between 0 and 1 of each of these points, which again, when plugged into the density filter, you can see we have the lower bound. Now remember, again, like I said, black represents 0, white represents 1. So if you can imagine now, the lower bound 0.868, that's quite light. That's quite a light shade of grey, 0.868. If, again, 1 is white, 0 is black. We're very close to white with 0.868. So essentially, anything that's like a vaguely dark point will be filtered out. So if I change the scale of the density filter and we debug that, undebug the noise and plug this in, you can see this is all that's left. Think of the density filter. I think a good way of thinking about it, in case this is, it might be a concept that you're familiar with. It kind of comes up quite a lot, the idea of filtering out certain values based on noise. But in case you're not familiar with it, think of it kind of like the minimum height requirement for a fairground ride. It's almost like saying, okay, if we have the lower bound at 0, everyone can get on this ride. Let everybody in. It doesn't matter how tall they are. Doesn't matter how short they are. No, it's just let them on. It's fine. It's like the most easygoing, like laid back ride you could ever imagine. But now let's say they, like, you know, some engineer comes in, tweaks the ride a little bit, cranks it up, makes it go a bit faster. Suddenly they need to add those pull down harnesses. Well, suddenly maybe you know, the short kings of the world won't be allowed on that ride. So, you know, they have to increase the lower bound to say, oh, now you have to be a minimum 0.8 meters tall to get on this ride. And all of a sudden, rip to the short kings, basically. So that's what's happening there. So hopefully that makes sense. We kind of yeah, if I go back now through the points, let's debug sequentially. Spline sampler is going to generate points. We have the interior sample space and is the distance that will be placed between those points uniformly. So at the moment, each point is 25 units, whatever this is. Is it Unreal units? I don't know what this translates to, centimeters maybe? That seems about 25 centimeters. Let's just assume that's correct. Each point will be 25 centimeters away from the points around it. Again, and all this is going to be happening within the spline. If you don't know, by the way, if you press G in Unreal Engine, you have like, I don't know what they call it, game mode, is it? But it hides all like the interface and stuff like that, which is pretty useful when you want to just take a look at things as they would look in game. But anyway, we have the spline sampler. Every 25 centimeters, we'll say. I think it's centimeters. I'm pretty sure an Unreal Engine unit is a centimeter, right? Or is it a meter? Whatever. They're 25 arbitrary uniform units away from each other. So if we lower this to say like 10, suddenly we have a lot more points, right? And this could be good in terms of kind of, it really makes it, once you've added some filters, it really makes it hard to spot that this is kind of like a grid formation. And again, you could even have it lower. Try not to crash my system. It might be a bad idea while I'm recording. Let's bring that back up to 25 because it scares me a bit. So yeah, but like I say, all these points are uniform, right? So without the noise, if we don't have the noise added in, we have all these points. Now let's take off the debug, put the debug back on the density filter, and we plug that in. We still have all the points because all of these points have a value of 1. So none of them will be getting filtered out by the density filter. Okay, so again, we add the density filter back in. So let's once again do this. Let's just do it sequentially. Spline sampler has given us points that are 25 units away from each point next to it, right? The spacing is 25, right? But all the points have a value of 1. That's not what we want. Well, I guess that might be what you want in some instances. If you were building like, I don't know, a procedural terracotta army, that could be, you might want it like that, or very close to this at least. But that's not what we want for mushrooms and organic environmental stuff like that. That's bad. We don't want uniformity like that because it doesn't really arise in nature necessarily. So undebug the spline sampler, debug the density noise, and again, if you press D on a node, you get the debug, which the debug just shows you the points and kind of what's happening with them. So yeah, the density noise, you can see we've added a whole bunch of randomness to these points and the values, and then once we run that randomness through the filter, we can adjust it accordingly. And if we bring it like right up, we lose even more points. And I'm pretty sure, since the density noise is assigning a value between 0 and 1 to every one of the points, there's a good chance that none of them actually have a value of 1. So if we max it out, yeah, we lose all of them. So of the points at the beginning, after they've been given some noise, none of them actually have a value of 1.0. They all have values in between, which is fine, you know. But like I said, you know, you can change this value. And again, you can do that in the opposite direction, where instead of filtering out the lowest values, we filter out the highest values, and we bring that all the way down on the upper bound. We're left with just the values with the points with a value of less than 0.176, or including. I don't know if it. I guess it would include upper bound 0.176. I guess it would include 0.176, but either way, I mean, whatever. So yeah, that's what we're doing there. And the other thing to remember as well, you're not limited to just one of these. So in the static mesh spawner, you can see on the index, it's an array of elements, meaning that if I plug this back in, and then okay, let me bring the density filter all the way back up again. If we go into the static mesh spawner, on the index, on mesh entries, we click the plus button, we get another index, and you saw some of the mushrooms get removed then. That's because of the points that were available to us after the density had been filtered, some of them now are spawning the thing in index 0, which is the initial mushroom, but some of them are now spawning the thing in index 1, which is actually blank. So those points are still there. It's just that the thing that's getting spawned on them is this index, which happens to be blank. So it is a good way of adding a little bit of, like, if you want to just remove a few points, you can just add empty indexes here. I don't know off the top of my head how inefficient that is, but it feels very inefficient to me. I don't really like when things are just floating without a value in there, but I suppose it is something to consider maybe if you wanted to. I suppose, I'm trying to think. I suppose it could, there are instances where that could be useful, but anyway, let's index 1. So we can go and we can add a second mushroom, for example. Yeah. So now on all those points where the first mushroom hasn't spawned, we now get a second type of mushroom spawning. So there's 2 different ones, because I downloaded a bunch. The mushrooms, by the way, are from Megascans. You can plug in any mesh that you want into this. The mesh itself is kind of arbitrary. They just happen to be a good kind of example for this. So yeah, what we can do here, we're not limited to just one of these. We can, you know, instead of doing it like this, where we have 2 meshes within one static mesh spawner, now what we can do is essentially, if we right click and add another density filter, we can sort of set up channels in which specific meshes can spawn. So if I duplicate these, Control D to duplicate, and then do this, And then go over here, change the mesh entry to a different mushroom, this one. But then what we'll do is in this density filter, so we can see this one has a range of 0.92 to 1. If we make this density filter have a range of, say, I don't know, 0 to 1.36, we essentially end up with two different channels. So this one is covering range 0.92 to 1. This one is covering range 0 to 0.136. And you'll see there's no overlap between these two filters. No overlap whatsoever. Which basically, and there's no overlap between these two filters, and the two filters are also pulling from the same noise, right? They're both using this randomly generated noise in order to create these filters. But because of that, it means essentially that you'll never have meshes spawning on top of each other if you do it like this, because a point in this, like a point that this filter would let through, this filter would never let through. Meaning that if you spawn a mesh on this one and a mesh on this one, those meshes will never overlap, and it means that you can go in and allow like different transforms. Let's say in this one, you don't want the transform to be 0.5 to 2 because, I don't know, maybe this mushroom's already kind of small. So you never want it to be 0.5, but you still want it to be 2. So you can do that. So then the meshes on this spawner will never be smaller than the base mesh, but can still be twice as big, which is pretty cool. So you can kind of add a lot of variation, and you can really fine tune the kind of the granularity of just how specific you can get with where you want things to spawn, how you want them to spawn, which kind of bandwidth you can things can spawn into. Bandwidth, I guess, might not be the real like accurate term to use there. I don't know the specific nomenclature, but I think it kind of gets the point across anyway. So yeah, so that's essentially what we're doing with like the noise. And I think it's an important concept to kind of understand. So that's kind of what's happening there. Well, not kind of, that is what's happening there. Let's delete this one though. We don't need all that. We're just going to keep it simple and just have the one. So hopefully that makes sense. Hopefully that's kind of intuitive enough to see what's happening there. And I think as well, it's important to remember, it's easy to start thinking of these points as merely a representation of a location in 3D space. So instead of thinking of them as merely a location on which to spawn a mesh, think of them instead as a container of multiple pieces of data, one of which happens to be its location in 3D space. But, you know, you can kind of contain all sorts of data within each point. You know, they're not really just a representation of a point in space. They are, like I say, they are kind of an array of information that you can use and kind of pass down the chain of command. So you can see here, the node is called transform points. So all this transformation data is actually getting added to the point itself. So if I disconnect this and we go in here, let's go to absolute scaling, go to 0.05, enter, and then we debug the transform points node. You'll see that the transformation data, you know, it's like I say, it's the transform points node. It's not the transform mesh node, it's transform points. So all this transformation data is getting stored within the point itself and then inherited by the mesh that we add to that point. But it's not the mesh itself, if that makes sense. We're not transforming the mesh. We're kind of transforming the mesh incidentally. We're actually transforming the point. And there's lots of things that you can do with the points that will be inherited by whatever comes next in the flow, in the chain of command, right? In the flow chart, in the order of operations, I guess. And I think that's a useful concept to keep in mind, and it will allow you to kind of not not have a limited viewpoint of what can be done with each point, and it kind of expands the potential that you'll see. It's not that it's complicated, it's just when you're plugging the stuff together, you don't always sit and think about what's actually happening, but it can be useful to kind of take a step back and really kind of dissect what is happening under the hood. And it's like, okay, we're getting points, and then like we're adding noise to the points, we're creating bandwidths within the points to put things on, we're transforming the points. So it's like, you know, you kind of adding everything on top of each other until eventually you get, well, the last point here is what we have. And then after all of this has been done, after all these filters and transformations, then we put the meshes on the points and we get a kind of varied array of mushrooms, in this instance spawning, but you know, you can put whatever you want on here. And I think it's, you know, it's a powerful tool set and a useful tool set. And another thing I said I was going to do, so let's do that now, before this video becomes like feature length. You know, we don't want to create a Chris Nolan movie here. We're going to add some attributes that we can tweak from within the blueprint, so that we never actually have to enter the graph to change some stuff. So let's parameterize the scale. Okay, let's say you're a technical artist, you are giving this tool to an environment artist, and the environment artist has no interest in going into the PCG graph, finding the transform points for the thing that they want to change, and going in and changing all the scale and stuff like that. And honestly, who can blame them? That stuff can get annoying. And this is a really simple node graph. These things can balloon out of control real quick. Like, good luck finding the exact right node that you need to change. It can get real annoying. So what we're going to do is add a parameter. We're going to expose one of these attributes so that we can change it from within the blueprint. So first of all, what we want to do is the get actor property. So yeah, right click, bring up this get actor property, click that. We got this handy little node here. So now on this side, under the properties, under property name, where it says none, you want to delete that and give it a name that will be recognizable to whoever's using this. So we're going to just call it, once again, my nomenclature shining through like a beacon of originality. We're going to call it mushroom scale max, right? Double click that, Control C to copy it. Okay, then we're going to go over here, back into the blueprint. Under variables, you're going to click the plus button and then press Control V while this is highlighted. Mushroom scale max. So that's important. The name here has to match the name here because it's essentially what it's going to be looking for. Think of it the same as the tagging system that we use for the spline. It's kind of like that, except it's not named tag. I don't know if maybe they'll change the way this is set up at some point, because I don't know, it felt a bit counterintuitive to me to just have a variable that's not connected to anything within the event graph of the blueprint. So I don't know, maybe that's just a me thing though. But anyway, so once you've done that, get act property, we've given the name of the property, and then we've created a variable. And bear in mind as well, the variable type does matter. Float works because it's a number, and it will basically pass this float into the scale max for each of these values, so it will scale uniformly across all of the axes. So the X, Y, and Z will all scale uniformly, so you won't get a mushroom that's like half as skinny but twice as tall, or some, you know, like weird funhouse mirror looking toadstool. It will scale across uniformly. How many times can I say uniformly in a 20-second period? Anyway, so once you've done that, you want to click the little eye icon, And the eye icon basically exposes this variable so that it's editable without coming in to the blueprint itself. I don't know if that makes sense. If you're familiar with blueprints, it will, but if you're not, just know you want the eye to be open, basically. Then you plug this, the get act property, plug it into the scale max, and if you didn't see, because I didn't actually explain it, there's a little arrow underneath this. So each one of these nodes does have some properties that you can expose in the blueprint. So for example, in the density filter, we have the lower bound and outer bound. So you could, the exact same way that we're doing here with get act property for the scale, you could do the same thing for the lower bound and upper bound of the density filter, for example, so that the environment artist could change the density without coming into the graph. You can really like make these endlessly customizable from the blueprint, which is another reason why I like nesting it inside of the blueprint, is so you can do this kind of thing. So anyway, we take this, the active property, mushroom scale max, we plug it in to scale max. Now you can see that they've disappeared. Why is that? Well, it's because this variable by default has a value of 0. So essentially the maximum scale that the mushrooms can be currently is 0, which means like non-existent. But if we take like, as you can see now, this weren't there before. Under the, let me bring this back. So if I select this, for example, if we select the blueprint, you can see we have, under all the settings and stuff, where all like the fancy Unreal options are, we now have our own little setting that's available to us that we just created. We're basically programmers at Epic Games. And we can drag this up and it will change the maximum scale of the mushroom without a little bit bigger than maybe is necessary there. Although it is kind of cool. You can create some weird alien looking environments with this kind of stuff. So yeah, that's how you add parameters, which is really useful and can save you a lot of time. Again, like I say, when these node graphs start getting complicated, it can become really annoying to start diving in and kind of changing stuff like that. So, you know, anything that you're going to be changing frequently, and you know, a lot of the vital settings that you want to be easily accessible, it might be worth parameterizing. You can also go a step deeper here. You know, this is kind of getting a little bit maybe more in depth and outside of the realms of PCG, but I think it's just, you know, fun stuff to include. If you go onto category, at the moment it's set to default, which is what it says here, but you could create a category here, for example, that says, I don't know, mushroom settings. And then if you compile that, it no longer says default, it says mushroom settings. So you can segment the settings and kind of make this look like really professional and like it actually belongs within the interface of Unreal Engine. So you don't just have like a default and then like 700 attributes. You can kind of, you know, compartmentalize this stuff and make it really user-friendly. Whether that user will be you in like a week's time or someone else if you're part of a bigger team. So yeah, another little thing that's maybe worth showing just because I find it to be kind of interesting. If you click add and then billboard, you can add a billboard component to this. And I compile now. So essentially, it can get difficult in case, like, you know, if this is buried underneath stuff or hiding and, you know, behind things or whatever, shoved in the environment. You can add a billboard and you can, you know, you can customize exactly like what image the billboard is. At the moment, it's just like the default little raptor dinosaur thing that's with Unreal Engine. But you know, if you wanted to make this tool really feel like it belonged and feel like, you know, part of the interface of Unreal Engine, you can kind of, you know, you can change that to a mushroom maybe or whatever, but basically just gives you like a handle that's a little bit more, if this is like buried under here, it's like, oh, how do I grab my thing? I don't want to be clicking the spline and stuff. You click the little raptor head and you can grab hold of it. Just a little little detail, little tidbit that makes it a little bit more usable. But anyway, I think that about covers it. Hopefully you found this useful. Hopefully the format was acceptable, and you know, splitting it into two halves of more of like the standard ABC of making it versus the kind of theory behind it was a good way of doing it. And you know, depending on what you wanted to get out of this video, neither should have interfered too much with the other. But that's it from me. If you happen to watch this, let me know in the comments what maybe you'd like to see next, what worked, what didn't work, you know, any issues you ran into, and also if you make some cool stuff in PCG, if you're like inspired by, you know, some of the things I talked about, and you kind of go and watch 100 other tutorials and make something incredible, then, you know, let me know. I'd like to see what people are doing with this, the kind of elaborate things people are making. But yeah, I think that's it from me, and I'll see you next time.